Good evening, and welcome to tonight's episode of Science to Sleep By. Tonight, we'll take a gentle journey beyond the boundaries of Earth, past the quiet glow of our own Milky Way, and into the vast cosmic ocean where galaxies drift, dance, and sometimes collide. You don't need to worry, these collisions happen so slowly, across billions of years, that they feel less like violent crashes and more like an elegant ballet written across the universe. As you listen, let the thought of these distant, graceful encounters carry you into a state of calm. Find a comfortable place to rest, let your breath slow, and allow the mysteries of the cosmos to guide you into sleep. Tonight's story is about what truly happens when galaxies collide, and why these extraordinary events are less destructive chaos, and more like the universe's way of creating beauty. When we look up at the night sky, we often see nothing more than tiny points of light scattered across a canvas of darkness. From here on Earth, those twinkling stars feel small, fragile, and almost within reach. But if we could step back, far beyond our solar system, beyond the familiar spirals of our Milky Way, we would realize that each of those stars is just a single piece of something far greater. They belong to galaxies, enormous collections of stars, planets, gas, dust, and invisible dark matter, bound together by gravity. Galaxies are the great cities of the cosmos, each one holding billions, sometimes even trillions, of suns. Our own home, the Milky Way, is just one of these countless cities, stretching across more than 100,000 light years. To cross it from one side to the other would take light itself, traveling at nearly 186,000 miles every second over 100,000 years. And yet, in the scale of the universe, the Milky Way is modest. There are galaxies so vast, so bloated with stars, that they put ours to shame. There are also tiny galaxies, dwarfs with only a few million stars, wandering through the cosmos like drifting embers. Each one follows its own path, its own trajectory, shaped and guided by the invisible hand of gravity. And here lies the beginning of our story. These galaxies are not isolated. They are not fixed in place, suspended in an eternal stillness. Instead, they move. They travel through the darkness of space, sometimes alone, sometimes in clusters, drawn together by mutual attraction. Their journeys take billions of years, but eventually, paths converge, and when they do, galaxies collide. Now, the word collision conjure up images of violence, of cars crashing, glass shattering, metal twisting under the force of impact. But in the cosmos, the meaning is far more subtle. Galaxies are not solid objects in the way we imagine. They are mostly empty space. If the Milky Way were reduced to the size of the continental United States, each star would be no larger than a speck of dust. The distance between them would be measured not in inches, but in miles. What we call a collision is not a crash in the ordinary sense, but a slow, majestic dance. Imagine two immense spirals of stars, drifting closer and closer together, their arms stretching and twisting as they feel the tug of each other's gravity. Over millions of years, their shapes distort, their elegant spirals pulled into long, glowing streams. Like dancers reaching out their hands, the galaxies extend luminous bridges of stars and gas between them. Eventually, their cores draw close, circling one another, weaving tighter until they merge into something new. The process is slow, almost serene, folding across time scales for longer than human history. What seems to us like a collision is, for the universe, simply another act of creation. For astronomers, these encounters are not rare accidents. They are essential events in the life cycle of the cosmos. Almost every galaxy has collided, or will collide, with another at some point in its existence. Our own Milky Way bears scars of past encounters, faint streams of stars stretched across the sky, remnants of smaller galaxies torn apart and absorbed into our own. And in the far future, billions of years from now, we too will meet our partner in this cosmic dance, the Andromeda galaxy. But before we imagine our own future, let us pause here, at the very beginning, and simply take in the grandeur of what a galactic collision truly is. To understand it, we must first appreciate the enormity of scale. A galaxy is so vast that even light, the fastest thing we know, takes tens of thousands of years to cross from one side to the other. Galaxies drift through clusters that can contain dozens, hundreds, even thousands of them, like islands in an ocean too large for the mind to fully grasp. Between them lies darkness, but not emptiness. Invisible webs of dark matter stretch out like scaffolding, guiding galaxies into clusters, groups, and filaments that span the entire universe. When two galaxies approach, it is not just their visible stars that interact. Their clouds of gas, their dust, their invisible halos of dark matter, all of these respond to the pull. From a distance, it looks like slow, inevitable attraction. From within, for the stars, it feels like an almost imperceptible shift in motion. A change so small it would take millions of years to notice. The stars themselves rarely collide. Instead, they pass one another, weaving new orbits, like fireflies shifting paths in a summer field. But the gas and dust tell a different story. They collide, compress, and collapse, igniting bursts of star formation. Entire generations of stars are born in the aftermath of these encounters. Brilliant clusters that light up the merging galaxies like fireworks frozen in time. It is easy, from our human perspective, to imagine such events as catastrophic. Yet in the language of the universe, they are creative. Collisions build galaxies. They transform simple spirals into grand ellipticals. They spark new stars that shine for billions of years. They bring black holes together in titanic mergers, sending ripples of gravitational waves through the very fabric of space-time. To watch two galaxies collide, even across the gulf of millions of light years, is to witness a process that has shaped the cosmos since its beginning. And though these events seem distant, almost unreal, they are also intimately connected to us. The heavy elements that make up our world, iron in our blood, calcium in our bones, oxygen in our lungs, were forged in stars that may have been born in the aftermath of ancient galactic encounters. Without collisions, without the reshaping and recycling of galaxies, the universe might not have had the richness required to create planets like Earth, or life like ours. So, as we begin this journey into the world of galactic collisions, let us set aside the image of violent crashes. Instead, imagine a quiet, graceful dance, vast beyond comprehension, yet delicate in its unfolding. Two galaxies approach, their arms outstretched, their stars drifting like glowing dust in the wind. Slowly, across millions of years, they circle and entwine, becoming not chaos, but harmony, destruction, but creation. And as you imagine this, let the thought bring you calm. Because in the end, galactic collisions remind us that even in the largest scales of the universe, beauty is not destroyed, it is reborn, over and over. In the endless ballet of the stars, if there is one force that quietly choreographs the movement of galaxies, it is gravity. Invisible, silent, and constant, gravity is the universe's unseen hand, guiding stars, planets, and galaxies in their eternal journeys. When we speak of galaxies colliding, what we are truly speaking about is the slow, inevitable work of gravity, drawing them closer, weaving their paths together in ways that unfold across spans of time so vast that a billion years becomes little more than a single note in the symphony of the cosmos. Here on Earth, we feel gravity as something simple. It is what keeps our feet planted on the ground. It is what pulls an apple from a tree. It is what gives weight to our bodies, pressing us gently toward the surface of our planet. But on the scale of galaxies, gravity is not just a familiar tug, it is the architect of the cosmos itself. Every star within a galaxy is bound by gravity to that galaxy's center. Every planet clings to its star because of gravity. The very shape of galaxies, the spirals, the clusters, the long filaments stretching across space, are sculpted by this force. Without gravity, the universe would be a scattering of lonely particles, drifting apart into nothingness. Imagine, then, two galaxies approaching one another across the abyss of space. Each is a giant in its own right, with hundreds of billions of stars spinning in orbits that balance delicately between motion and attraction. At the center of each lies a supermassive black hole, a concentration of mass so great that not even light can escape it. Around this heart, stars circle in immense arcs, held steady by the balance between their forward momentum and the pull of gravity. For billions of years, these galaxies may drift peacefully, unbothered, until gravity introduces them to each other. At first, the pull is almost imperceptible, a tiny curve in their paths, a slow bending of their trajectories. Over millions of years, they draw closer to us, observing from afar. It looks as though they are gliding across the dark sea of the cosmos, two luminous islands approaching, guided by an invisible current. As they near the edges of their halos, those vast spheres of stars, gas, and dark matter that surround each galaxy begin to interact. The galaxies feel each other's presence. They begin to tug, not violently, but gently, like dancers circling before they finally take each other's hands. What is extraordinary about this dance is its scale. From our human perspective, collisions are immediate. A car crash takes only seconds. A falling stone strikes the ground in an instant. But galaxies move in a rhythm that is almost impossible for us to imagine. Their approach, their first encounter, their eventual merging, all of it takes place over hundreds of millions, even billions, of years. If we could watch it in real time, we would see nothing but stillness. Yet sped up across cosmic time, it becomes a ballet, arms of stars twisting and stretching, glowing bridges forming between the galaxies, their shapes transforming with each gravitational pull. Gravity does not act in sudden jolts. It acts with patience. Each star within a galaxy continues its orbit, but now, those orbits are subtly altered by the presence of another galaxy nearby. Some stars are drawn outward, flung into long, trailing streams that can extend for hundreds of thousands of light years. Others are nudged inward, sinking closer toward the galactic core. The galaxies themselves begin to distort, their once perfect spirals twisting into elongated shapes, like ribbons caught in a gentle wind. And as the dance continues, the galaxies may pass through one another, not once, but many times. Because space within a galaxy is mostly empty, stars rarely collide head-on. Instead, the galaxies interweave, pass through, separate, and are pulled back together again, like two dancers moving in and out of step, their paths bound by the invisible thread of gravity. With each pass, their shapes grow less distinct. Spirals unravel. Long tidal tails of stars and gas arc outward, tracing delicate patterns in the darkness. Slowly, the two galaxies lose their individuality, merging into a single, larger galaxy, reshaped by the encounter. But this dance of gravity is not confined to visible matter alone. Around every galaxy lies an enormous halo of dark matter, mysterious, unseen, yet containing far more mass than the stars and gas we can detect. Though we cannot see it, dark matter is a vital partner in this cosmic choreography. When galaxies collide, their dark matter halos are the first to feel each other's pull. They pass through, overlapping and intermingling, creating gravitational fields that guide the visible parts of the galaxies. Without this dark matter scaffolding, the dance would lose its balance. It is as though the visible stars are the dancers, while the unseen dark matter is the stage upon which they move, defining the shape of the performance. On Earth, when we watch two dancers move across a stage, their steps may appear graceful and effortless, but behind them lies discipline, rhythm, and invisible music. In the same way, galactic collisions may look chaotic, but beneath the apparent disorder, there is an elegant structure created by gravity. Every twist of a spiral arm, every stream of stars, every orbit shifted and rearranged, it all follows the same simple law of attraction, the same universal rhythm that holds the cosmos together. Consider what this means for us. The Milky Way is not drifting randomly through the void. It is part of a group of galaxies, known as the Local Group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller companions. Andromeda, our nearest large neighbor, is bound to us by gravity. We are moving toward each other at incredible speeds, over 250,000 miles per hour. Yet, because the distances are so vast, this approach will not culminate in a meeting for another 4 to 5 billion years. In human time, that is forever. In cosmic time, it is inevitable. We too are part of this galactic dance, even if we will never live to see its most dramatic steps. What makes this so soothing, so humbling, is the patience of it all. Gravity teaches us that the universe does not hurry. It does not rush. It does not force. It simply pulls, steadily and quietly, until galaxies that once seemed far apart are drawn together, until structures that once seemed stable are reshaped into something new. What feels like chaos to us is, in reality, a deeper kind of order. So, when we speak of galaxies colliding, we are not speaking of destruction. We are speaking of transformation. We are speaking of a dance so vast and so graceful that it stretches across billions of years, a choreography written into the very fabric of space-time. To imagine it is to imagine movement on the grandest possible scale, two spirals of light, circling, stretching, entwining, until they become one, their stars continuing their orbits, their gravity finding a new balance, their forms merging into a galaxy that carries the legacy of both. Gravity is the quiet composer of the universe. It writes the music of motion, guiding every planet, every star, every galaxy, and even the unseen scaffolding of the cosmos into a delicate balance. To us, gravity may feel ordinary, even mundane. We know it as the pull that keeps our feet on the ground, that lets a ball fall from our hands, that holds the oceans in place and governs the rhythm of the tides. Yet when we step back, when we lift our gaze from Earth to the great stage of the universe, gravity reveals itself as something far more profound. It is the invisible hand that sculpts galaxies, the patient choreographer of their movements, the quiet force that turns emptiness into order. When we speak of galaxies colliding, what we truly mean is that galaxies are caught in a dance arranged by gravity. These immense collections of stars, gas, dust, and dark matter are not wandering randomly. Each galaxy, no matter how far away, is influenced by the gravitational pull of its neighbors. Like partners circling in a vast ballroom, galaxies draw nearer, guided not by chance, but by the steady attraction of their shared mass. And though the dance takes billions of years to unfold, the steps are inevitable. Gravity ensures that what is drawn together will someday meet. To understand this dance, we must first imagine the galaxy itself as a system in balance. A spiral galaxy like the Milky Way is made of hundreds of billions of stars, each one in orbit around the center. What keeps these stars from simply falling inward is their motion. They are moving forward, always forward, like planets orbiting the sun. Gravity pulls them inward, but their motion carries them outward. The result is a perfect compromise, an orbit, a circular path around the galactic center. It is a delicate balance, maintained for billions of years, as though every star were a dancer moving in time to an inaudible rhythm. At the very core of each large galaxy lies a supermassive black hole, millions or even billions of times more massive than the sun. This dark heart does not simply sit in isolation, it anchors the dance. Stars circle around it in great spirals, their movements governed not just by the black hole itself, but by the collective mass of all the stars and dark matter within the galaxy. The galaxy is a system of motions nested within motions, each orbit a thread in the larger choreography of the whole. But galaxies do not exist alone. They cluster together, forming families bound by gravity. The Milky Way belongs to the local group, a collection of galaxies that includes our great neighbor, the Andromeda galaxy, as well as the smaller Triangulum galaxy and dozens of dwarfs that drift like glowing sparks around the larger giants. Gravity binds this group together just as surely as it binds the Earth to the sun. And over time, gravity pulls its members closer, until eventually they begin to interact, to circle, to merge. The first steps of this cosmic dance are subtle. When two galaxies drift within range of one another's gravitational influence, their shapes begin to change. From afar, you would not notice it in the span of a human life. But given millions of years, their arms stretch outward, tugged by the pull of their partner. Tidal forces caused by the uneven pull of gravity across each galaxy draw out long streams of stars, stretching them into glowing arcs that trail through the void. These tidal tails can extend for hundreds of thousands of light years, fragile filaments of light sculpted by invisible attraction. As the galaxies draw closer, their centers begin to circle one another. They may pass through each other once, not merging immediately, but continuing onward, only to be pulled back again. To us, this seems strange. How can something collide and then separate, only to collide again? The answer lies in the scale of space. Galaxies are mostly empty. Though they may contain billions of stars, the stars themselves are so far apart that the chance of two ever colliding directly is vanishingly small. A star is like a grain of sand, and the distances between stars are like miles of empty desert. When galaxies pass through one another, their stars glide silently past, each one tugged gently onto a new path, but never striking another. The dance continues in cycles, one pass, then another. Each time, the galaxies lose more of their distinct form. Their spirals unravel, their arms distort. They pull streams of stars behind them like ribbons trailing in a breeze. Slowly, over hundreds of millions of years, the two galaxies settle into one another, their stars finding new orbits, their gas clouds colliding and compressing to form bright bursts of new stars. What began as two separate structures becomes one larger, more luminous than either alone. Gravity, patient and tireless, has completed its choreography. And yet, even in this merging, the dance continues. Deep within each galaxy lies that central black hole. When galaxies unite, so too do their black holes. At first, they orbit each other, like twin partners circling in the darkness. It allows them to unfold at their own pace, with each stage lasting longer than all of human history combined. This slowness is not a flaw but a feature. It is what allows galaxies to transform without tearing themselves apart. It is what allows stars to survive, to continue shining even as their galaxies reshape around them. The slow motion of these encounters is what makes them graceful rather than catastrophic, ordered rather than chaotic. If you were to speed up time, condensing millions of years into seconds, the process would appear dramatic. Spirals would twist, arms would stretch, stars would stream outward like sparks, and cores would merge in luminous bursts. But when we slow it back down, returning to the true pace of the cosmos, the violence dissolves into serenity. What remains is a quiet unfolding, a rhythm too vast for us to measure, but one that speaks of patience, of inevitability, of beauty written into the very structure of the universe. In this way, galactic collisions remind us that not all change is sudden. Some of the most profound transformations happen slowly, gently, across spans of time so long that they defy comprehension. Just as mountains on Earth rise and erode over millions of years, just as continents drift silently across the surface of the planet, galaxies too reshape themselves in silence, their collisions more like the slow growth of a tree than the shattering of glass. They are not moments, but processes, not endings, but transitions, not chaos, but choreography, written in the language of gravity and performed across the stage of the universe. When we hear the phrase, galaxies colliding, it is natural to imagine stars smashing into each other in brilliant, fiery explosions, as though the heavens themselves were filled with countless suns crashing together like sparks in a fire. After all, galaxies are home to hundreds of billions of stars, each one burning with its own light, each one enormous in size and power compared to our small Earth. How could such a vast number of stars come together without chaos, without countless impacts lighting up the cosmos with destruction? And yet, the truth is far stranger, and in its strangeness, far more beautiful. Despite the incredible number of stars inside galaxies, space itself is unimaginably vast. The distances between stars are so immense that even during the most dramatic galactic mergers, the stars themselves almost never collide. To give perspective, Imagine the Sun reduced to the size of a small marble. At that scale, the nearest star to us, Proxima Centauri, would be another marble placed more than 500 miles away. That is how empty space truly is. Even when galaxies intertwine, their stars are like fireflies drifting past one another in the night, shifting paths slightly, but never striking directly. So what happens then to the stars during these grand collisions? They are not destroyed. Instead, their paths are altered. Gravity becomes their silent guide, reshaping their orbits, bending their journeys through space into new patterns. Some stars may be flung outward, cast into the vast reaches beyond the main body of the galaxy, becoming lone wanderers that drift through the dark, forever separated from their galactic home. Others may be drawn inward, sinking closer to the dense centers where the gravitational pull is strongest. Many remain bound to the galaxy as a whole, continuing to orbit in harmony, even as the galaxy itself takes on a new form. In this way, galactic collisions are less about the destruction of stars and more about the rearrangement of their great cosmic city. Picture a bustling metropolis, with roads and avenues filled with countless vehicles. If the entire city were gently lifted, twisted, and shifted into a new shape, the cars themselves would not crash into each other en masse. Instead, their paths would bend, rerouted by the new structure of the city, continuing their motion, but along altered routes. In much the same way, stars adapt to the gravitational reshaping of their galaxies. There are, however, places where the fate of stars takes a more dramatic turn. While stars themselves rarely collide, the vast clouds of gas and dust that drift between them behave differently. When two galaxies merge, their interstellar gas is compressed, shocked, and stirred into dense regions where gravity takes over once again. These clouds collapse, giving birth to whole clusters of new stars. In the aftermath of a collision, a galaxy can light up with brilliant starburst activity, creating millions of fresh suns in just a few million years, a brief spark of creation. Compared to the slow timescales of the galaxies themselves, some of these newborn stars are massive, burning hot and blue, destined to live short, luminous lives before exploding in spectacular supernova, enriching their galaxies with the heavy elements that will someday form planets, oceans, and life. Meanwhile, the older stars, those already burning for billions of years, continue their quiet existence, unaffected by the turmoil around them. Our own sun, if it survives long enough to witness the merger between the Milky Way and the Andromeda galaxy billions of years from now, will not collide with another star. Instead, it will drift into a new orbit, perhaps cast farther from the galactic center, perhaps closer, but still shining steadily for as long as its fuel allows. From Earth, if life still remains, the night sky would transform into something extraordinary. The heavens would fill with the brilliant light of Andromeda's stars, drawn close and stretched across the sky. Over millions of years, the patterns of constellations would shift beyond recognition, replaced by unfamiliar arrangements, dazzling in their strangeness. But the stars themselves would remain, their fates determined not by destruction, but by graceful rearrangement. And yet, even though direct collisions between stars are rare, they are not entirely impossible. In the densest regions of galaxies, near the crowded cores where stars orbit close together, encounters can occur. Two stars may come close enough to influence one another, perhaps exchanging material, perhaps even merging into a single, larger star. Such events are extraordinary, the exception rather than the rule, but they remind us that even in the vastness of space, chance meetings can shape new destinies. The merging of stars can give rise to exotic objects, like blue straggler stars that appear younger and hotter than their surroundings, created by the fusion of two smaller stars into one. The movement of stars during galactic collisions also has another profound effect. It can reshape entire galaxies. A spiral, with its elegant, curving arms, may lose its form, its stars redistributed into a new shape. Over time, the merged galaxies may settle into an elliptical galaxy, a vast, smooth collection of stars without the delicate spirals of their former selves. In this way, the fates of individual stars contribute to the destiny of the galaxy as a whole. Their motions, shifted by the encounter, collectively weave the structure of the new, larger system that emerges from the union, and deep within, the most massive stars, born in the bursts of star formation triggered by the collision, may come to an end in cataclysmic explosions. These supernovae seed the galaxies with heavy elements, enriching the cosmic environment. The iron in our blood, the calcium in our bones, the oxygen we breathe, all of these elements were forged in such stars long ago. Collisions, by stirring galaxies and igniting new stars, play a direct role in creating the ingredients for life. Without them, the universe would remain a simpler place, filled only with the lightest elements, unable to form the complex structures we know today. The stars, then, are not passive bystanders in galactic collisions. They are participants in a slow transformation. Their orbits were written, their births and deaths influenced by the great merging of galaxies. Some are cast adrift, becoming intergalactic wanderers, glowing alone in the darkness between galaxies. Others remain bound to their new home, part of a structure that will shine for billions of years into the future. And still others, born in the fiery aftermath of colliding gas clouds, will blaze brightly and die young, leaving behind black holes, neutron stars, and the heavy elements that enrich the cosmic cycle. Think of what happens to stars in these encounters is to glimpse the vast interplay between permanence and change. Stars themselves can live for billions, even trillions, of years, burning steadily through the ages. Yet their fates are not entirely their own. The galaxies they inhabit shape their paths, guiding them into orbits that may endure for eons, or casting them outward into lonely exile. And when galaxies collide, the stars are gathered up in the choreography of gravity, their courses shifted, their destinies altered, not with sudden violence, but with patient, graceful inevitability. In this way, galactic collisions remind us that even the most powerful and enduring lights in the sky are part of something larger. They are woven into patterns of motion that span billions of years, patterns that transform galaxies themselves, patterns that give rise to new stars, new elements, and new possibilities. And as we imagine the stars drifting, circling, and reforming, in the slow embrace of colliding galaxies, we are reminded of the beauty of change, not as destruction, but as the creation of something new, something larger, something enduring across the endless expanse of time and space. When galaxies collide, it is not the stars themselves that define the most dramatic transformations, but the gas and dust that lie between them. These invisible and often overlooked components of galaxies, vast clouds of hydrogen, helium, and heavier elements, along with fine particles of cosmic dust, are the true architects of creation during these events. They are the raw material from which stars are born, the breath of the universe condensed into brilliant, luminous suns. Without gas and dust, galaxies would be quiet cemeteries of ancient stars, their light fading slowly into silence. But with these elements, stirred and shaken by collision, galaxies come alive with bursts of creation, igniting new generations of stars that light the heavens. To understand the role of gas and dust, it helps to imagine them as the interstellar ocean, in which stars float. Though invisible to our eyes, this ocean is vast, filling the spaces between stars with tenuous, delicate filaments of matter. In a calm galaxy, this gas and dust drifts slowly, moving in gentle currents, occasionally clumping into denser clouds, where new stars may be born. But when two galaxies approach one another, gravity pulls not only on the stars, but on this ocean as well. The gas and dust is dragged, stretched, and compressed, like tides surging under the pull of a nearby moon. As galaxies interpenetrate, their gas clouds collide in ways that stars never do. Unlike stars, which are small points in the vastness of space, gas clouds are sprawling, diffuse, and prone to interaction. When they meet, they slow each other, compressing into denser regions. These collisions trigger waves of compression that ripple through the galaxies like shock fronts, squeezing gas into knots of higher density. And in these knots, something remarkable begins. Gravity takes over. Gravity, the patient sculptor of the cosmos, pulls the atoms of hydrogen and helium closer and closer together. As density increases, the clouds fragment, breaking into smaller, denser clumps. Within these clumps, pressure builds, temperatures rise. At last, fusion ignites, and stars are born. In this way, galactic collisions serve as catalysts for creation, igniting bursts of star formation that can transform galaxies into dazzling beacons of light. Astronomers call these events starbursts. They are episodes in which galaxies produce stars at a rate hundreds of times higher than normal. In a starburst galaxy, millions of stars can form in just a few million years, a brief moment on cosmic timescales, yet one that reshapes the galaxy forever. These newborn stars burn with intensity. The most massive among them blaze blue-white, hotter and brighter than the sun by orders of magnitude, their light flooding space. Though they live only a few million years before exploding as supernova, they leave behind the heavy elements that enrich the galaxy. The smaller stars, formed alongside them, will endure for billions of years, their gentle glow lighting the future long after the fire of the starburst has passed. Dust, too, plays its part in this drama. Tiny grains of carbon, silicates, and metals. Dust may seem insignificant compared to the vast clouds of gas, but dust absorbs and scatters light, shaping the way galaxies shine. In colliding galaxies, dust can be drawn into great lanes and filaments, weaving dark, intricate patterns across the glowing backdrop of stars. These dust lanes obscure some regions while revealing others, creating galaxies that appear both turbulent and beautiful to our eyes. Within these dusty cocoons, stars are often born, shielded from harsh radiation until they are ready to emerge. The interplay of gas, dust, and gravity during collisions is not just an astronomical curiosity, it is a process that shapes the very possibility of life. The heavy elements that form planets, oceans, and biology are born in stars. But to make those stars, galaxies need the raw material of gas and dust. Collisions accelerate this cycle, pushing galaxies to create vast new populations of stars, which in turn enrich the cosmos with carbon, oxygen, iron, and all the elements that make complexity possible. Each time galaxies merge, the universe becomes a little richer, a little more capable of producing worlds like our own. Consider what this means for our own galaxy, the Milky Way. Billions of years from now, as it merges with the Andromeda galaxy, its gas and dust will be stirred into waves of creation. Starbursts will light up the combined galaxy, giving rise to entire generations of stars. New planetary systems may form, some perhaps destined to host life. For any civilizations that might emerge in those distant futures, their origins will be tied directly to the gentle turbulence of that collision, to the way gas and dust were compressed, ignited, and transformed. In colliding galaxies that we observe across the universe, we see glimpses of this process already underway. The Antennae galaxies, for instance, located about 45 million light-years away, are two spirals locked in a cosmic embrace. Their collision has triggered vast regions of star formation, visible as brilliant blue clusters scattered throughout their distorted forms. These clusters are nurseries of creation, where thousands of young stars shine together, newly born from the chaos of the merger. Dust lanes twist across the galaxies like brushstrokes on a canvas, marking the flows of matter that feed this ongoing transformation. The Whirlpool Galaxy offers another example. Though not in a full collision, interacts with a smaller companion, and even this minor encounter has stirred waves of star formation. Along its spiral arms, bright knots of newborn stars sparkle like jewels, each one the product of compressed gas and dust. In galaxies throughout the universe, wherever collisions occur, the same story repeats. Disturbance leads to compression, compression leads to collapse, collapse leads to light, but starbursts, like all bursts of energy, are temporary. Eventually, much of the gas is consumed, locked into stars or expelled by powerful winds driven by supernova and the radiation of massive stars. After the frenzy of creation, galaxies settle into quieter phases, their star formation rates declining. Yet, the stars that remain continue to shine, reminders of the brief, fertile chaos that gave them birth. In this sense, gas and dust are like the fertile soil of a cosmic garden. Stirred by collision, they give rise to blooms of starlight. When the soil is depleted, the bloom subsides, leaving behind the enduring beauty of what was created. Dust also preserves memory in its own quiet way. By absorbing light, it allows astronomers to peer into star-forming regions with special instruments, revealing the hidden process of birth. It holds chemical clues, containing the elements forged in earlier generations of stars. Each grain of dust is a relic, a fragment of stellar history, carried through space and time to seed new creation. In collisions, dust becomes a vehicle for transformation, spreading the ingredients of life and binding together the narrative of the cosmos. The role of gas and dust in galactic collisions teaches us something profound about the universe. It is not only destruction that arises from impact and upheaval, but renewal. The turbulence of a merger does not extinguish light, it amplifies it, channeling chaos into creativity. Where galaxies collide, stars are born. Where dust gathers, planets may someday form. And where gas collapses, the fires of fusion ignite, producing the brilliance that fills the skies. The stars we see tonight in the quiet sky above us are reminders of countless such events. Each one carries within it the history of gas and dust, compressed long ago, perhaps in collisions, perhaps in calm isolation, but always through the patient work of gravity. Each one is a beacon of the cycle that collisions accelerate the endless transformation of matter into light, of silence into brilliance, of darkness into life. At the heart of nearly every large galaxy lies a mystery so dense, so powerful, and so transformative that it shapes the life of the galaxy around it, a supermassive black hole. Unlike ordinary stars or planets, these black holes are not objects with surfaces, but regions where gravity is so strong that not even light can escape. They are invisible to the eye, yet their presence can be felt in the swirling dance of stars around them, in the jets of energy that blast across intergalactic space, and in the way galaxies evolve over time. When galaxies collide, these hidden giants are drawn into the cosmic ballet. They too are pulled by gravity, moving slowly toward one another as their galaxies merge. The journey of supermassive black holes during galactic collisions is one of the most profound stories the universe tells, a story that combines mystery, power, and unimaginable timescales. To understand the role of these black holes, we must first imagine their stillness. In the center of a calm galaxy, a supermassive black hole often rests in relative quiet. Surrounding it is a region of stars, gas, and dust, drawn by its pull but orbiting in stable patterns. Occasionally, a star may wander too close, torn apart by tidal forces, its remains swallowed. But for the most part, supermassive black holes in undisturbed galaxies are like sleeping giants, silent and nearly invisible. Collisions, however, awaken them. When two galaxies begin their slow intermingling, their central regions rich in stars and dense clouds of gas are disrupted. Gravity channels rivers of gas and dust toward the centers, funneling material inward like water flowing down a drain. For a supermassive black hole, this is a feast. As the material spirals in, it forms an accretion disk, a whirling, heated structure where friction and compression release extraordinary amounts of energy. The black hole itself remains hidden, but the disk blazes with light across the spectrum: X-rays, ultraviolet, visible, and radio. When this process unfolds on the grandest scales, we witness the birth of a quasar. Quasars are among the brightest objects in the universe, powered by matter falling into supermassive black holes. In colliding galaxies, the inflow of gas can ignite these titanic engines, causing the centers to outshine the entire galaxy. From Earth, we see them as distant, brilliant points, their light traveling billions of years to reach us. They are beacons of the early universe, reminders of how collisions can stir sleeping giants into furious activity. But black holes do more than shine. They shape their galaxies through feedback. As gas is drawn inward, powerful winds and jets can be launched outward, driven by magnetic fields and the immense energy of the accretion process. These jets can extend thousands, even millions, of light years, blasting into intergalactic space and heating the surrounding medium. They can quench star formation by blowing away gas, or they can trigger it by compressing clouds in the galaxy's outskirts. In this way, supermassive black holes are not just passive consumers, but active sculptors of galactic life. Now imagine what happens as two supermassive black holes, each at the center of their merging galaxies, begin their slow approach. For hundreds of millions of years, they spiral closer, drawn together by the dynamical friction of stars and gas that carry away their energy. At first, they may form a binary system, orbiting one another at vast distances, each with its own entourage of stars. Gradually, their orbit tightens. The space around them becomes chaotic. Stars flung outward at incredible speeds. Some ejected entirely from the galaxy. These ejected stars, known as hypervelocity stars, race into intergalactic space, forever unbound. As the two black holes draw nearer, their dance accelerates. They orbit one another faster and faster, generating ripples in the very fabric of spacetime. These ripples are gravitational waves, predicted by Einstein a century ago, and only recently observed directly by instruments like LIGO. In the final moments of their spiral, when they are just light years apart, the gravitational waves grow stronger, carrying away immense energy. Finally, in a fraction of a second on cosmic timescales, the two merge, collapsing into a single, larger supermassive black hole. The merger releases more energy in gravitational waves than all the stars in the universe emit in light during that instant. Yet to us, it passes silently, for gravitational waves ripple invisibly through space, stretching and compressing distances in ways that only the most sensitive detectors can perceive. Somewhere in the universe, even now, such mergers are unfolding. Their signals traveling toward us, waiting to be detected. For the galaxies involved, the union of their black holes marks a profound transformation. The new, larger black hole settles at the center of the merged galaxy, a giant reigning over billions of stars. Its mass may be millions or billions of times that of the Sun, a concentration of gravity so immense that it anchors the entire structure. Around it, stars continue their orbits, dust lanes coil, and gas flows inward, feeding occasional outbursts. This black hole, born of collision, carries the memory of two galaxies within its mass, a silent record of their union. There is something humbling about this process. It reminds us that collisions, though violent in imagination, are in reality slow and graceful, unfolding over billions of years. They remind us that destruction and creation are often two sides of the same coin. Stars are born in the chaos of colliding gas, while black holes grow through the merging of galaxies. The universe balances silence and fury, stillness and movement, darkness and light. Supermassive black holes are central to this balance. Without them, galaxies would be less structured, less sculpted, less dynamic. Their influence extends far beyond their invisible boundaries, touching stars, gas, and dust, across tens of thousands of light years. They are, in a sense, the heartbeats of galaxies, silent, steady, yet capable of sudden, brilliant flares when fed. And when galaxies collide, those heartbeats grow louder, pulsing with energy that reshapes the cosmos. If we look far into the night sky, beyond the familiar constellations, beyond the glow of the Milky Way, we see galaxies scattered across the darkness. Some are calm, isolated spirals. Some are irregular, warped by past encounters. And some shine with the brilliance of quasars, their cores lit by hungry black holes. Each of these tells a part of the same story, the story of how gravity binds, how collisions transform, and how black holes grow. The Milky Way, too, will one day at its chapter, when it merges with Andromeda, its central black hole, Sagittarius A, will meet Andromeda's black hole. They will spiral together, slowly, inexorably, until they unite. The stars of both galaxies will continue their orbits, largely untouched, but at the heart of the new galaxy, a larger black hole will reign, marking the union of two great spirals into a single cosmic city of stars. As we drift into thought, perhaps even towards sleep, it is comforting to remember that these processes, while immense, are also serene in their timescales. They unfold so slowly that even civilizations rising and falling over millions of years would see little change. To us, they are distant spectacles, their beauty revealed through the patient work of telescopes and observatories. To the universe, they are part of its natural rhythm, its endless cycle of birth, transformation, and renewal. When galaxies collide, we often imagine chaos, stars smashing into one another, planets torn from their orbits, suns flaring and dying in violent bursts. But the truth is far more delicate, far more serene. The fate of stars and solar systems during these grand encounters is not one of destruction, but of transformation, of drifting rearrangements, and of slow, graceful movements that take place over spans of time so vast they defy the human imagination. To begin, we must first remember the scale of space. Even within our own Milky Way, stars are separated by enormous distances. If the Sun were the size of a marble, the nearest star, Proxima Centauri, would be another marble placed hundreds of miles away. In such vast emptiness, the chance of two stars colliding, even during a galactic merger, extraordinarily small. So when galaxies pass through one another, their stars mostly slip past like grains of sand scattered across a wide beach. This is the great reassurance of galactic collisions. Stars themselves rarely collide. Instead, their orbits shift, pulled by the combined gravitational forces of the merging galaxies. Imagine billions of stars, like dancers in a vast, slow-moving ballet, weaving new paths across a growing stage. Some are pulled closer to the center, where the gravitational pull of black holes and dense star clusters dominates. Others are flung outward, carried on tidal streams that stretch into intergalactic space, forming faint, beautiful arcs of stars that trace the history of the collision. For solar systems like ours, the story becomes even more fascinating. Planets cling tightly to their stars, bound by gravity far stronger than the influence of the larger galaxy around them. So even when their star is nudged into a new orbit, the planets continue to circle in peace, unaware of the vast forces at play on a galactic scale. If our Sun is one day shifted by the Milky Way's collision with Andromeda, Earth and the other planets will continue their familiar revolutions, sheltered by the Sun's steady pull. Yet not everything remains untouched. The paths of stars can change dramatically, some cast into elongated orbits, others pushed closer toward the galactic center. A few are given so much energy during gravitational encounters that they are ejected entirely, racing into the darkness. As hypervelocity stars, these runaway suns, dragging their planets with them if they have any, become wanderers of the intergalactic void, carrying within them the seeds of solar systems flung far from their original homes. Meanwhile, in the crowded hearts of merging galaxies, the density of stars increases. Here, the chance of encounters grows, and gravitational tugs can disrupt orbits. A star passing too close to another can destabilize planetary systems, sending some planets inward toward their star or outward into the lonely dark. For most, stability remains, but for some, collisions mark the beginning of a new, uncertain journey. Beyond individual stars and solar systems, entire regions of galaxies undergo profound change. Clouds of gas and dust, once drifting quietly in spiral arms, are compressed by the gravitational turbulence of the merger. Compression sparks waves of star formation, igniting nurseries where new stars are born in staggering numbers. These regions shine with the blue-white light of young, massive stars, brilliant but short-lived, destined to burn out in just millions of years compared to the billions of years that quieter stars endure. These bursts of star birth transform galaxies, painting them with dazzling clusters and shaping their structure. Many of these young stars are born in groups, forming open clusters and associations that may one day drift apart, leaving their members scattered across the galaxy. Some stars form with planets already circling them, new solar systems created amid the chaos of colliding galaxies. In this way, galactic collisions do not simply rearrange what already exists, they also create the conditions for entirely new beginnings. The fate of solar systems in these new galaxies is tied to the balance between order and chaos. For most, life continues quietly. Stars move into new neighborhoods, their systems intact, their planets orbiting steadily. The night sky above those planets, however, would change dramatically. Constellations would shift as stars migrate, new patterns forming across the heavens. In some worlds, nearby galaxies would fill the sky, glowing arcs of light where once there was only darkness. To beings who might one day gaze up from such a world, the universe would look alive with movement, a reminder of the cosmic dance their star is part of. The long-term fate of stars is also shaped by their life cycles, and collisions play a role here too. As galaxies merge, many massive stars are born in rapid bursts. These stars, with masses many times that of the Sun, live fast and die young, ending their lives as supernova. These explosions seed the galaxy with heavy elements: carbon, oxygen, iron, the building blocks of planets, oceans, and perhaps life itself. The merger of galaxies, therefore, becomes a source of enrichment, scattering the ingredients for future solar systems more complex than those that came before. For stars like our Sun, the fate is gentler. These stars will live through the galactic collision with little disruption, slowly burning their hydrogen, then swelling into red giants before casting off their outer layers to form planetary nebulae. Their cores, left behind as white dwarfs, will shine faintly for billions of years, drifting wherever the galaxy's gravity takes them. The merging of galaxies will not alter their destinies, only their surroundings. Perhaps the most haunting thought is the journey of the stars flung far from the centers of their galaxies. Some will end up in the faint halos of the merged galaxy, orbiting in vast, elongated paths. Others will leave entirely, traveling alone through intergalactic space. These lonely travelers, carrying with them any planets they may host, would become tiny islands of light adrift in darkness. Their skies would be empty, devoid of nearby stars, their galaxies faint smudges in the distance. Yet even in such isolation, life could still persist, sheltered by the warmth of a parent star, unaware of the immense journey underway. And so the fate of stars and solar systems in colliding galaxies is not one of destruction, but of reshaping, renewal, and dispersal. Some remain bound in familiar orbits, some are carried into new patterns, some are cast out into the void, and some are born anew from the raw material of gas and dust stirred into life. The galaxies may lose their old shapes, their spirals stretched and torn, but their stars endure, carrying on their quiet lives under the influence of gravity's patient hand. The story of our own galaxy's future reminds us of this resilience. When the Milky Way meets Andromeda, the Sun will likely survive, along with Earth and the other planets. Our solar system may be carried into a new orbit within the merged galaxy, perhaps closer to the center, but perhaps farther away. The night sky will shift, filled with new stars and clouds, a panorama of cosmic beauty stretching across the heavens. And eventually, the two galaxies will settle into a single, enormous elliptical galaxy, its stars moving in new harmony, its black holes united at its core. The fate of our Sun will remain the same, steadily shining, gently evolving, unaware of the grand collision shaping the galaxy around it. From this perspective, we see that galactic collisions are not violent cataclysms in the way we might imagine, but slow, transformative events. They guide the journeys of stars, they seed the birth of new ones, and they spread the materials needed for planets and life. They are not endings, but continuations, new chapters in the universe's endless story. Stars and solar systems are not destroyed by the merging of galaxies, but carried into new arrangements, like pieces of a puzzle shifting into a new image, beautiful in ways we cannot yet fully imagine. When we speak of galaxies colliding, we often think of the momentary drama, the stretching of spiral arms, the bursts of new stars, the elegant dance of cosmic matter rearranging itself under the pull of gravity. But beyond the dance lies a deeper question. What is the ultimate destiny of these collisions? What becomes of the galaxies after they have passed through one another, merged together, and settled into a new form? To understand this, we must look not only at what happens in the immediate aftermath, but also at the long, slow future that unfolds over billions of years. When two galaxies meet, their encounter is not a quick event. It is a process that unfolds over hundreds of millions, sometimes billions, of years. First, their outer halos of dark matter brush against one another, tugging at their orbits. Then the stars and gas begin to shift, spirals stretching and twisting as tidal forces reshape their structures. After this first encounter, they may pass through each other, continuing on their paths, only to be drawn back together again by gravity. Over time, repeated passes pull them closer until, finally, they merge into one unified system. The shape of this new system depends on many factors: the mass of each galaxy, the angle of their encounter, the amount of gas and dust they contain, and the role of the supermassive black holes at their cores. When spiral galaxies like our Milky Way and Andromeda collide, the result is often not another spiral, but a massive elliptical galaxy, more rounded, less structured, and filled with older stars. This is because the orderly rotation of the spirals is disrupted, and the stars are stirred into more randomized orbits, creating a shape that is smooth and oval rather than flat and spiraled. Elliptical galaxies born from mergers are often quieter than their spiral predecessors. In the collision, much of the available gas and dust is either used up in bursts of star formation or swept into the galaxy's center, feeding black holes and forming new stars at the core. Once the gas is consumed, little remains to fuel the birth of new stars. Over time, the galaxy grows older, its bright, hot stars burning out, leaving behind cooler, longer-lived stars that give the galaxy a softer, redder glow. In this way, a collision may ignite a brilliant era of star birth, but ultimately, it leads to a calmer, quieter destiny. At the center of the merged galaxy, the supermassive black holes of the original galaxies find each other. These are giants, millions or even billions of times the mass of the Sun, and their meeting is one of the most extraordinary events in the universe. They orbit one another for millions of years, gradually drawing closer as they release energy in the form of gravitational waves, ripples in spacetime itself. Eventually, they merge into a single, even larger black hole, anchoring the new galaxy at its heart. The central black hole continues to shape the galaxy, influencing the orbits of stars and the flow of gas. In some cases, it may erupt as a quasar, blazing with light as matter falls into it at incredible speeds. In others, it may lie quiet, an unseen presence holding the galaxy together. The destiny of colliding galaxies, then, is not destruction, but transformation. They become larger, more massive, often calmer systems that continue to evolve over billions of years. The Milky Way and Andromeda, for example, are destined to merge about 4 billion years from now. At that time, the Sun will still be shining, and Earth will still orbit it. From our planet's perspective, the night sky will change dramatically. Andromeda will grow larger in the sky, its spiral arms stretching across the heavens until, eventually, the two galaxies blend together. The stars will form new constellations, brilliant arcs of light painting the dark with patterns unseen in today's sky. As the two galaxies settle, our solar system may be carried into a new orbit, perhaps closer to the center of the merged galaxy, or perhaps farther away. Either way, Earth's view of the cosmos will never be the same. If humanity, or any life at all, remains to witness it, they will look up at a night sky filled not only with stars, but with clouds and streams of light that mark the legacy of the Great Collision. What we call the Milky Way will no longer exist as we know it, but instead will have become part of a vast new galaxy, sometimes referred to as Milkomeda or the Milky Andromeda. But what happens after this? What is the longer-term fate of galaxies once they have merged? Over time, the merged galaxy will grow quieter. The starburst triggered by the collision will fade as the gas runs out. The young, massive stars formed in those bursts will burn quickly and die in supernova explosions, leaving behind neutron stars and black holes. The slower, steadier stars will remain, gradually aging and cooling. As billions of years pass, the galaxy will take on a reddish hue, the color of ancient stars living out their quiet lives. Eventually, galaxies like Milky will drift together with other nearby galaxies, pulled by the mutual attraction of gravity. Over tens of billions of years, galaxy groups and clusters will merge, forming even larger structures. The local group, which includes the Milky Way, Andromeda, and dozens of smaller galaxies, will become a single massive elliptical galaxy. These larger structures will continue to evolve until, one day, the expansion of the universe carries distant galaxies beyond our cosmic horizon, leaving only the galaxies of the local cluster bound together. In the far future, then, the universe will look very different. Where today we see billions of galaxies scattered across the sky, one day, only the remnants of local mergers will remain visible. For civilizations existing trillions of years from now, the night sky will appear empty, their galaxy isolated in a vast, silent universe. They may never know of the cosmic collisions and dances that once shaped the heavens, yet within those galaxies, stars will still shine, planets will still orbit, and the echoes of collisions will remain written in the patterns of stellar motion, in the arcs of tidal streams, and in the mass of the great central black holes. Even as the universe grows darker, the legacy of galactic collisions will endure, for they are not merely events of the present but part of the universe's ongoing story. And so, the ultimate destiny of colliding galaxies is to become something new, larger, calmer, and more enduring. They merge, they settle, they grow, and they transform. They fuel starbursts and quasars, they seed the cosmos with the elements of life, and then they fade into quiet majesty, holding their stars in gentle orbits across the ages. Their story is not one of violent ends, but of rebirths, of transformations, and of the patient unfolding of time on the grandest possible scale. As we drift back from this journey through the cosmos, we find ourselves holding onto a vision that is both humbling and comforting. Galaxies, those vast cities of stars, are not fixed or permanent. They are in motion, carried along the tides of gravity, emerging and transforming. What we see in the night sky is only one chapter in their much larger story, a story that stretches over billions upon billions of years. We have seen how gravity shapes their destinies, guiding them into slow-motion ballets across the universe. We have imagined the stars shifting into new constellations, the gas and dust igniting into brilliant new star nurseries, and the supermassive black holes at their cores finding one another in the deep silence of space. We have looked ahead to the future of our own Milky Way, bound to meet Andromeda in a grand union that will reshape the sky forever. And as we reflect on this, we are reminded of perspective. Our human lives are but a blink compared to the timescales of galactic collisions. Yet, in that brief moment, we are able to look up, to wonder, and to understand. That is the gift of science and imagination, that we may lie here on a quiet evening, feeling small and yet deeply connected to something far greater. So, as you close your eyes tonight, let the thought of galaxies colliding not bring fear, but peace. These cosmic events are slow, graceful, an inevitable part of the universe's way of creating beauty. You are resting under the same stars that will one day drift into new shapes, carried by the same cosmic currents that shape entire galaxies. And in that thought lies a kind of serenity, a reminder that you are part of this vast, unfolding story of time, space, and wonder.